Hello once again. This is my Burgess Safari Lite. Burgess? I don't know. From 1973. This is a portable fluorescent lantern. I made a video about this before. This was a very early portable fluorescent lantern. One of the earliest, actually. These were introduced in 1966. And it is a very cool portable fluorescent lantern because rather than using a modern electronic ballast that generates the high voltage needed for the 8-watt fluorescent lamp, this has a simple resistive ballast and required special high voltage batteries, almost proprietary batteries, for the high voltage to run the lamp. This took two 69-volt batteries wired in series, so 138 volts nominal. And those were big, tall batteries, two of them in the battery compartment. And early lanterns, Burgess claimed that the batteries could run the lantern for up to 40 hours. On later units like this one, they claimed it could run it for up to 20 hours. So maybe they were a bit overzealous with their claim for the early units, who knows. So yeah, it's a standard resistive ballast, meaning there's just a resistor in series with the fluorescent lamp to serve as the ballast, and the high voltage comes directly from that 138 volts from the battery pack. There's also a magnetic ballast inside here for use on AC current, so there's a little plug right there where you can plug in a cord and run this on AC power, and it's just a standard magnetic ballast. And of course it's preheat because of the way it works. So a preheat portable fluorescent lantern, that's pretty darn cool. And there's also high and low brightness settings. When you put it on low, a secondary resistor is inserted in line with whatever's being used as the ballast at the time, and it halves the lamp current. So the lamp current is split in half, and the lamp runs at a dimmer setting. The purpose being to save battery life at the expense of brightness. So this is a really cool fluorescent lantern, and they're actually very common and cheap to get. You can buy one of these on eBay for as little as 10 bucks. eBay's just littered with these. And perhaps part of the reason that so many of these were made is because of a very cool bit of history with these. These were actually tested by the U.S. military in Vietnam. A bunch of these were sent to U.S. soldiers in Vietnam for use in the field. So a bunch of these did go to Vietnam and serve in the war, which is pretty darn cool. They ended up not being used full scale. The tests ruled that although the Safari Lite was a very useful device and a very nice, bright, portable light, it ultimately just wasn't fit for military use. One, because they deemed the lantern not rugged enough for military use, in particular because it's not waterproof. And two, because the special high voltage batteries they used, weren't as readily available as, say, standard flashlight batteries at the time, low voltage batteries. And they had to mail in battery special whenever anybody requested new batteries for their Safari Lite. They ultimately deemed it not worth putting into full-scale use in Vietnam, and that was the end of the test. But they did test them there, and that's pretty darn cool. But something sad is that although this is meant to be a portable fluorescent lantern, you can't use these portably anymore because the special high voltage batteries that these used went extinct decades ago, like 40 years ago. You haven't been able to buy batteries for these in decades, and that's too bad. So if you get one of these, all you can do is run it on AC current, which is somewhat useful, I guess, but certainly not as cool as being able to run one of these fully portably. Well, when I made the video about this thing a few years ago, one of the main points I made in the video was that someday I wanted to find a way to be able to operate this portably again. Well, I have finally done that. I'll demonstrate it right now. Observe. Of course, we are not plugged in. We're running totally portably. I'll start it up here. And there you go. Are you not amazed? Well, maybe not, but still, it's really darn cool. Yeah, for you know, probably the second time in this thing's entire 45-year life, it's running on DC power. And this is for realsies. I haven't changed out the ballast or modified the lantern at all. It is running on the original equipment in the original fashion that it was designed for. And in this video, I'm going to show you how I've done it. Put it on low brightness here. There's low brightness. Back to high brightness. And shut it off. So, how have I done it? Well, I have to open up the battery compartment to show you. So let me do that and then we'll come back. Okay, so I've got the battery cover opened here. There are two ways that I could have gone about this. The first way, which is the one that I thought I was going to eventually do for a long time, was to basically recreate the original battery, the original high voltage battery. And the way I thought about doing that is, of course, for the past several years, I've been collecting I've been pulling 18650 lithium-ion cells from laptop batteries or whatever, and I've amassed a good collection of them. I've got like 30 or 40 of them now. So when you do the math, you could string around 35 lithium-ion batteries in series and get enough voltage to recreate the original battery pack that this used. So that was my original plan that I thought of. Wire like 35 18650 cells in series, shove it all in here, and that would be my battery pack. But eventually, it actually took a couple of years and some discussion and reading and stuff to decide against it. But there's some problems with that. First of all, it would be statistically extremely dangerous to do. Because obviously lithium-ion batteries, as good as they are today, they're not perfect. You know, they're inherently not as safe as alkaline or carbon zinc or lead acid batteries. Lithium-ion batteries sometimes fail. Once in a great while, they fail catastrophically. And when you have two cells wired together in a pack, you have double the chance of a cell failing. If you have 3 cells in a pack, you have triple the chance. Now extend that to 35 cells wired in series, and the chance of something bad happening is astronomically high. It could have never happened. Perhaps I could have gone for years and years and never had a cell fail, or statistically more likely, a cell would have failed at some point in such a way that something catastrophic may have happened. And 35 lithium-ion cells is a lot of chemical energy in one big pile, and you have one battery blow up and the other catch fire, and you've got a massive, almost a bomb on your hands, pretty much. So that was what ultimately made me decide against it. The other problem is you have 35 cells, all wired in series. You have to have balancing circuitry so that, of course, cells, you know, when you have lithium ions, when you have any batteries wired in series, you want balanced circuitry to keep the voltage of each cell of the series battery equal. Or else you may have one battery that's sitting in its nominal voltage and the other battery that's sitting lower than that. And as the batteries continue to drain as you use the device, you eventually may end up with a cell being under-discharged. So I'd have to have balancing circuitry, and 35 cells would require balancing circuitry for 35 cells, and that would be a lot of circuitry, a lot of extra wiring. Now you have the risks that come with a ton of wiring everywhere, and you know, if a single wire pops out and possibly shorts against something else, it's just a recipe for disaster almost. Every little thing has to be perfect, or else you could have a really bad situation on your hands. So eventually I decided against making a big high voltage battery pack. Other people have done that before. I know someone who has a Safari Lite, and they made a battery pack out of AAA cells. And it works great for them. The only problem is, of course, is that AAA cells are expensive and not rechargeable. This person made a pack for use with non-rechargeable AAA cells because if they wanted to use rechargeable cells, they would have needed a lot more cells because of the lower nominal voltage. So this person had, I think it was like, I forget, it was like 80 or 90 AAA cells in series. And it works for them, and it runs the lantern for a long time, because if a AAA is like, I forget what modern AAAs are, 1 amp hour or 1.5 amp hours, if we just say 1 amp hour, and the current for this thing running on high brightness is like, let's say around 100 milliamps, nominal, average, whatever, that theoretically gives you 10 hours of runtime off of 80 or 90 AAA cells, so not bad. So it's a little expensive to replace the battery once it's dead, but you still have a lot of capacity to work with, and it runs the lantern for a long time. Another possibility is using 9-volt batteries. 9-volt batteries would be quite convenient because you only need, what, like 15 of them to get the required voltage? But of course, 9-volt batteries aren't as high capacity. They're usually around, I think around 600, 700 milliamp hours. So it's only going to run for a few hours, and 9 volts generally aren't cheap, so it's still quite expensive. So a primary battery pack is really just an expensive way to go about it, because once it's dead and you have to refurbish you have to buy all new cells for it, that gets really expensive. Maybe if you bought a massive amount of them in bulk, you'd save a bit of money that way, but still quite expensive. But going with a rechargeable battery pack is a more dangerous way to go about it, because rechargeable batteries are generally more volatile than their primary counterparts, especially when you get to the lithium-based battery technologies. And then there's all the problems with cell balancing and stuff. So it's just really complex either way, and personally, I don't think it's a great idea anymore. So what about the second way that I could have gone about this, which is the way I ultimately chose? Well, I bought for $5 on eBay a DC to DC converter. It takes in a low DC voltage and it converts it to a high DC voltage. In particular, the module I got off eBay, you can power it with between 10 and 32 volts, and it can output up to 395 volts DC. And obviously that's plenty of headroom for my needs. Like I said, the nominal voltage of the original battery pack in this thing was only 138 volts, so an adjustable 395 volt source, adjust it down to near that voltage, and you're good to go. So that's what I did. Let me show you inside here. And there is what's inside. There's the module that I bought on eBay. If I remember, I will link to this on eBay so you can take a look. Cost me about $5, shipped from China, and it's been working just fantastic. I have it set to output 115 volts. I did a lot of testing. I tested different voltages and measured the lamp current at those voltages and how hot the converter got, and eventually what I ended up doing was choosing a voltage that struck a good medium between the lamp being driven decently and the converter not overheating, because this is not a high-powered converter. In fact, it states that it can output a maximum current of only 200 milliamps, and that's with the output voltage equal to the input voltage. The higher you put the output voltage, the lower the efficiency gets, and therefore the more heat the converter creates given a output current. So I found that if I put the voltage at the point where the lamp would be driven at absolute full power, this got a bit hot. It actually has terminals on it for a fan, but I wanted to see if I could get away with not having to use a fan. And I was able to get away with not using a fan. I found that running at 115 volts drove the lamp decently. Lamp current is about 100 milliamps. The rated lamp current for an 8-watt fluorescent lamp is about 140 milliamps, so you're running really decently, certainly way better than modern portable fluorescent lamp fixtures with their cheap instant start ballast too. So no problem there. And the converter just gets a little warm, just a little more than lukewarm, so definitely no problem there. Efficiency was also a factor, of course. The more power that you make the converter output, the less efficient it gets. So I also measured the efficiency of the converter. At really low currents, efficiency is around 80%. I found with higher currents, efficiency got down to as low as 60-65%. As I have it set now, efficiency is about 75%. So yeah, I think I struck a happy balance there. I did test to see how low of a voltage I could go before there wasn't enough voltage to actually run the fluorescent lamp, because of course there is a minimum to that. An 8-watt fluorescent lamp has an arc voltage of about 60 volts. I found that I could get down to about 90 volts before the voltage was too low and the arc extinguished. So yeah, I was able to do a lot of playing around, a lot of testing and measurements just for my own interest to see how things run. But yeah, I set this to 115 volts, and that seems to strike a happy medium. Way back in the day when I was on Lighting Gallery, I don't go there anymore because I found in my last few months there, there was an explosion in membership, and it seemed to be mostly kids and stuff that were into this stuff, which I think is great, except that, you know, kids don't always know how to behave in a mature manner on an internet forum, and I certainly understand that. I was one of them. When I was a preteen, early teen, I always didn't know the proper way to conduct myself. But there was, you know, in the last few months that I was on Lighting Gallery, there was a big explosion in membership, a lot of young people coming there, and things started to get out of hand. There were more, you know, flame wars and stuff in forums, and eventually I moved on to other hobbies anyway, and I just grew tired of it, and I quit going there. I check in once in a great while. I definitely need to check in so I can post this video there, because I think a lot of people would be interested to see this there. But I remember back when I was on there, somebody told me once that when you run a fluorescent lamp on DC current, the rated lamp current is less than when it's running on AC current, because when you're running on DC current, rather than each cathode only being having an electrical load on it for half the time, because AC current is a sine wave, of course, you're on one half of the sine wave for half of the time, and then the other cathode's heated for the other half of the time. Whereas on DC current, you have one cathode heated the entire time. And so lamp current needs to be lower, or else you're going to overheat the cathode and shorten the life of the lamp. I forget what that percentage would be. I don't know if you know, how much lower of a lamp current you should have for DC. So I just put it at what I thought would have been a safe value, 100 milliamps, whereas the rated AC current for an 8-watt lamp is 140 milliamps. I think that's probably a safe amount to go. So yeah, I set this at what I think is an optimal way to go, and I can adjust it later whenever I want. If I want to turn the voltage up someday, get a bit more lamp power or whatever, I can do that. So that is the converter. And how it works is, the output of the converter, I have wires going down to the battery terminals, and I just soldered them on there. You can see, battery terminals are made of brass or something, so I couldn't solder to them, but down in the very center of the terminals were just barely poking out in the center were the wires that go to the ballast. So I was able to solder to those and attach the output wires coming from the converter. And then what about a power source? What am I using for a battery source? Well, I'm using a lithium-ion battery pack composed of 3 18650 cells. So these are providing the low voltage that's powering the DC to DC converter. And you may notice something new here, this little switch. I had to cut a hole in the bottom of the body of the lantern, and as you can see, I did not a very good job of that. Lessons learned. I used a Dremel to do that. And this switch was salvaged from a dead computer power supply. And the reason I had to put this in here is, of course, if I were to just wire the converter directly to the battery pack, the converter would be running all the time, and the converter does have a significant quiescent current, which is the current that the converter draws even if there's no load on it. I forget what it was, but it is enough that if you were to leave this for a few days, even not turned on, the quiescent current drawn by the converter would eventually drain the battery pack. So I had to put a secondary switch here, which disconnects the battery pack from the converter. When I want to run the lantern, I just turn that on, and if I turn my light off here, you can see there's a power LED on the converter. And once this switch is turned on, I can start the lantern using the power switch on the lantern. So that's how that works. And yeah, that's what I've done. I've run this for a total of maybe only 15-20 minutes so far. And it's been running great. Of course, because I'm using only a 3-cell battery pack instead of a 35-cell battery pack, and because of the power loss that comes from having to use a DC-DC converter, battery life's obviously going to be way inferior to what the original batteries would have provided. Just based on rough math, if I use good quality 2 amp hour cells, they're wired in series, so a total capacity of 2 amp hours, and the lamp current is 100 milliamps at a voltage of 115 volts. That is a total power of 11.5 watts. Add some for the efficiency of the converter, let's call it 13-14 watts. From the battery pack, 2 amp hours by a nominal 11.1 volts is 22.2 watt hours. And then 14 watts into that, it's going to be like an hour and a half of runtime using good quality 2 amp hour cells with the lamp on high. If I put the lamp on low brightness, that should theoretically double, so maybe 3 hours of runtime. So a very far cry from the original 20 or even 40 hours that Burgess specified for the original batteries. But it's rechargeable, so it's not a great big deal. And the other thing is, there is so much more space, empty space here. I could put in a larger battery pack if I want. In the future, if I want to, I could upgrade this to 6, 9, maybe even 12 cells. I could have a really nice big pack going on here that could run this for many hours. But I need to start small right now because this isn't even finalized yet. I am running with no cell balancing circuitry right now, and that's why I haven't run this thing a whole lot or done a battery life test or anything, is because I have no balancing circuitry right now. I'm just running this thing raw dog. I have put in cells that are matched in capacity, but sometimes that's not good enough. I have, in tests with lithium-ion battery packs before, I have found that even matched capacity cells, if you drain them far enough, you do end up having that one cell that ends up discharging way more than the others. So I need to get some balancing circuitry. I bought a 3-cell balance circuit for 99 cents on eBay. It's coming from China, so I'll see that some year. And once I get that in, I can put that in there. And that circuit also provides charge protection, so when you charge the cells, that circuit will cut off the charge current once the cell voltage reaches 4.2 volts. Because right now, as it is, I have to remove these cells to charge them. And I'd like to not have to do that. I'd like to be able to just keep the cells in the lantern all the time and be able to charge the lantern, charge the cells while they're inside the lantern. And how I plan on doing that is, I want to drill a hole, maybe back here, and yeah, that would work. Drill a hole back here, and install a barrel jack, just a standard low voltage DC barrel jack, and then I can use like a 12 volt power supply, a 12 volt AC adapter or whatever. Just plug the barrel jack in there, and that'll charge the batteries, and the balance and charge circuitry will do all the work to make sure the cells are properly charged and balanced. And I think that'll work pretty well. And gee, you know, once I do that, I won't even have to plug in the AC cord anymore. If I want to run this on AC power, I could just plug in an AC adapter jack, and it would work just fine running from the AC power, still drawing from the battery pack, but the AC adapter would be providing charge current at the same time. So yeah, not finalized yet, but I think I've got a good start on this, and once I get the balance circuitry and everything else, I think I'll have a really nice system going on here, and then in the future, if I want, I can explore expanding the battery pack for more capacity. Nice. Very, very bright lantern. And there's the low brightness setting. Very cool. So that is how you take a 45-year-old fluorescent lantern whose exotic batteries went extinct 40 years ago and make it able to run on battery power once again with no modification to the ballast required. The original way the lantern works is preserved, but of course, unless you have a fancy converter that somehow is able to shut itself off when there's no load, you just need to add a secondary power switch for the converter. So I'm super happy with this. It took me years to finally do this, but I'm really glad that I finally got around to doing it. I'm looking forward to being able to improve on this with built-in internal charging and a balance circuit, and down the road perhaps expanding the battery pack to a 6 or 9 or even 12 cell battery pack. Oh, sort of something funny you can sometimes observe. Because the fluorescent lamp is being run with DC current. Now this is a vintage lamp that I'm running in this. This is a Philips TL8W33 from 1970. And because this is preheat and drives the lamp with a decent amount of current, I'm not worried about lamp life being shorted. For this being a portable lantern, whereas with a modern instant start fluorescent lamp fixture, I would never run a vintage lamp like this in that, because lamp life would be extremely shortened. With this device, it should last just as long as if it were in a mains powered fluorescent lamp fixture. But something funny you notice is when fluorescent lamps, namely modern fluorescent lamps, run on DC current, you get what's called Mercury migration. The DC current, where only one cathode is active, it causes all the mercury in the lamp to migrate to the end of the lamp with the active cathode. And I'm motioning like this because in this particular fixture, when the DC power source is wired as it should, the top of the lamp is the active cathode. So what you get is all the mercury migrates towards the active cathode. Now in a vintage lamp like this one, there's absolutely no problem with that, because vintage fluorescent lamps were given a healthy dose of mercury and you don't see any effect. But with modern lamps that have less mercury in them, just because of the whole environmental and toxicity fears that surround mercury that I think's slightly overblown, but I digress. Where modern lamps don't have as much mercury, it's fine on AC current usually, but when you run a modern fluorescent lamp on DC current, all the mercury migrates to one end, and what you get is the half of the lamp with the active cathode is brightly lit, and the other half is super dimly lit. And I actually have a photograph here I'll show you of a modern lamp that I ran in this lantern, and you can see the upper half of the lamp is nice and bright and the lower half is just completely dim. So that's sort of one downside to a lantern like this that drives the lamp with DC current, is you get that mercury migration with a modern lamp, and you end up losing about half the brightness, because the upper half is running at normal brightness and the lower half isn't lit up at all. So you lose half the lamp brightness, which is obviously not very good. So something like this, you're best to run vintage lamps, or at the very least modern lamps that are known to have a healthy dosage of mercury. I own a number of new old stock Hitachi 8-watt lamps that a lighting gallery user sent me a few years ago they're modern lamps, but they have plenty of mercury in them, so they don't migrate in this lantern, so that's good. So yeah, I've got a good stock of lamps that I can use in this thing that will not suffer from mercury migration as a result of running on DC current, so that's good. So there is my newly modified Burgess Safari Lite fluorescent lantern from 1973. Really happy to be able to finally run this portably. I've owned this lantern for 6 years, and it's always been my dream to get it to run off battery power. And now that I've finally accomplished that, I think this thing will be getting a lot more use for power outages and the like. It's an extremely bright lantern. Like I said, way better performing than anything modern that you can get today. Although you can't really buy modern portable fluorescent light fixtures anymore. Everything's LED now, which of course is a superior technology as far as performance and battery life is concerned. But I can't get enough of these vintage fluorescent lanterns. Just some of my favorite things. Also, because I haven't mentioned it already, I can't stress this enough, working with DC voltages as high as what this thing uses is hazardous, possibly dangerous. High voltage DC is more dangerous than even high voltage AC, because with high voltage AC, because the AC voltage reaches a 0 point in the sine wave every 60th of a second, you have that 60th of a second where your muscles aren't being contracted and you can yank your hand or whatever away. With DC voltage, you don't have that zero crossing, so as soon as you grab onto it, your muscles are being contracted by the DC current and they're going to stay that way. So unless you manage to gain enough control over your muscles to pull it away, you could be in a really bad situation. So I definitely don't recommend you do something like this unless you know how to work with things like converters and how to safely work with high voltage power. So be safe if you do something like this. So there you go. Thank you so much for watching, and I'll see you next time.